again, we're going to go over how to show a quadratic, a cubic, and linear regression on a TI-84 calculator. Alright, the equation for the linear regression is y equals mx plus b. Quadratic, it is y equals ax squared plus bx plus c. For the cubic, it is y equals ax to the third plus bx squared plus cx plus d. To keep this class fun, I will give a joke after I go over a certain thing from each of the different types of regressions. First joke, y plus 2 equals 4. Y equals 3. That's not right. Y equals 2. The type of information we're going to put on the calculator is that of a quadratic model. We're going to use information I found about the percentage of households engaged in gardening from 1990 to 2000. Click on Stat. You can see it here or right here. Then you're going to click Enter on Edit. Luckily, I already put in the information. We're going to measure the amount of percentage in gardening using in thousands, and we're going to use 1990 to 2000 starting from 0 to 10. For example, 1995 would be equal to 5. Once we're at this point, we have the information which I've written over here. We're going to click on Second, Quit, then we're going to go to Stat, over to Calc, and because we know, we're going to see if it's a quadratic regression by clicking on Enter, and then down, 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 Calculate. And this is where we're going to find our equation. And wow, the r squared is 1. That's the perfect portrayal that this is a quadratic expression. Okay, so we saw the numbers on the calculator, and here I put it into the equation. So the a is negative 0.5, the b is negative 1.5, the c equals 80, and the r squared doesn't go into the equation, but it just gives an example of how close a number is to 1. That means it's that type of regression. Okay, now that we have this equation, we're going to go on a calculator to y equals and just plug it in. Y equals negative 0.5x minus 1.5x plus 80. And then we're going to click on Trace, and voila! This is the scatter plot of our data. Now that we're finally done with a quadratic regression, it's time for a joke. What's my math teacher's favorite kind of baby? A newborn! A cubic regression. We're doing the most difficult kind next, so at the end, you could practically teach yourself how to do a linear one. Okay, so it's a very similar process to the quadratic. You're going to click on Stat, Edit, and edit the L1 and L2. Luckily, you have a great instructor like me, and I already put it in. Then, we're going to do Second Quit, do Stat, Calc, and then because it's a cubic regression, we're going to click Enter all the way down to Calculate, and this is how we're going to get all the different things for our equation. Alright, so once you have the equation, again, you can just go to y equals and plug it in the calculator. So 0.015x to the third minus 0.595x squared plus 9.15x plus 98.4 is going to be your cubic regression. And then you're going to do Second Quit, and then you could just click on Trace. And here's your scatter plot of that information, which I've drew over here. It's a very simple process once you get the hold of it. I love math! Now that you probably understand a cubic regression, I have another joke for you. What do you call a military vehicle with an E on it? A tank-E. Ba-da-ba. Alright, the linear regression I found is actually a really cool one. It's about Americans who are going to live to be over 100. I'm going to start in 1990 like I did with the quadratic and put it in on my calculator. So again, we're going to go to stat, edit. Oh wait, I already put it in. I forgot. So for example, with the years, we're going to start with 1990. So 4 will be 1994, 6 will be 1996, etc., etc. In L2, we're just going to do like what we did before. So stat, calc, this is a linear regression. Down, calculate. And voila, here are our numbers. Alright, once we have that, we can just go second quit. And then we can just, get the equation. And put it in. I already put it in because I'm way ahead of the game. Alright, then we're going to second trace it. Sorry, first trace it. And here's a scatter plot. Alright, and see how it gives you the dots and the line? Before I've just been writing the lines, but now I'm going to show you how to get the best fit line from it. The final joke of this project. It's been a long ride. So the final joke I'm going to say in dolphin, but there's going to be a subtext on the sheet for you mere mortals. Just kidding. I will get an A on this project. Parting remarks. 1. Part of this project was saying why the TI-84 is just the best calculator and better than other calculators like the TI Inspire. This is a very simple calculator, but it gets the job done. We're able to do everything we need without using a very complex computer-like calculator. I said y equals mxb, but the correct equation is y equals axb. A and m are interchangeable. Alright, the r squared. Whichever equation has an r squared of closest to 1 is the type of equation which best summarizes the data. Quadratic and cubic regressions, I just drew the best fit line without the scattered plots. On the calculator, it's really the scatter plots, the dots with the numbers, but I drew an estimated best fit line, which I showed how to do in the linear regression. That is how you do linear, cubic, and quadratic regressions along with jokes. I would have just been playing Xbox all day on this Sunday, but instead, I showed you how to do math on a TI-84 the right way. Have a great day. That's all for Math with Ben today.